So coming on to next section, which have integer type questions. Question number 43 says that let a polynomial px when divided by x minus 1, x plus 1, x minus 3 leave the remainder 3, 5 and 9 respectively if px is divided by the product of these three monomials x plus 1, x minus 1, x minus 3 and then the remainder is capital R of x, then what is the value of R of 4? So this is a very standard problem, so let us solve it by the standard procedure. Okay. So in the first step, I can write that px is equal to x minus 1 into, let the quotient be a of x plus 3. Okay. Then I can write that p of x is equal to the second divisor, that is x plus 1. Let the quotient be b of x plus remainder is 5. P of x equal to the third divisor is x minus 3 into the quotient, let it be c of x plus 9. Now what do I need? I need the solution of this equation. Px is equal to x minus 1, x plus 1, x minus 3 into some quotient, let it be d of x plus capital R of x, that is given in the question. Okay. Students, you can very well observe that the degree of the remainder is 1 less than the degree of the divisor. If the divisor is monomial, as it is happening in first three equations, the remainder is a constant value. Over here in the fourth equation, the divisor is of degree 3. So the remainder can be assumed as a polynomial of degree 2. So this is x minus 1 into x plus 1 into x minus 3 into quotient plus ax square plus bx plus c, p of x. Now what you have to do? Repetitively you have to put x equal to 1, x equal to minus 1 and x equal to 3. So what is p of 1? P of 1 is 3. What is p of minus 1? P of minus 1 is 5. And what is p of 3? P of 3 is 9. So you have to use these three values to solve the value of ax square plus bx plus c, where we have three unknowns and three equations. So p of 1, let us put 1. This term will be 0. A plus b plus c will come out to be equal to 3. Then let us put x equal to minus 1. A minus b plus c will be equal to p of minus 1, that is 5. Let us put x equal to 3. So 9a plus 3b plus c equal to 9. If I subtract these two equations, I will directly get the value of b as minus 1. Then I will get a as 1 and c as 3. So Rx is basically ax square plus bx plus c. X square minus x plus 3. Let us calculate R4 quickly. R4 will be 16 minus 4, that is 12. 12 plus 3, that is 15. So the answer of this question is equal to 15. Okay. Let us move on to question number 44. Next question is question number 44 based on the chapter sequence in series. If the number of identical terms of the series 193, 186, 179 up to n terms and minus 315 up to 49 terms is 6, then the maximum value of n is. So obviously we will deal with question by finding the common AP first of all. Minus 315, this AP we know the number of total terms. So let us write this AP first. Minus 315. The 49th term will be minus 3 plus 48 into the common difference, that is 4. The AP is minus 315, so on till the last term will be 192 minus 3, that is 189. We have to find the number of common terms in this AP and the given AP 193, 186, 179. Common difference of first AP is d equal to 4. This AP is d equal to 7. So the common ratio of common AP has d is equal to 28. So I will have to make a smart move now. Obviously, we'll have to find out the first common term in both the APs. So when I figure out the second AP, 193, 186, 179, 172, 165 and so on up till nth term, let us say an, I figure out that 165 is the first common term. Okay, so the common AP is 165, then 137, then 109, 81. So as the question says that we have to write 6 terms common. So let us identify where the 6th term is there. Okay, so after 81 we will have 53, and after 53 we will have 25, and after 25 we will have -3. Okay, so here is the catch. -3 and -3. So -3 is coming out to be a term of common AP, and this is the 7th common term. But the question says that we need to have only 6 common terms. Okay, then what is the maximum value of n? So that means I need that particular value of n जहां पे 193 वाले AP का ब्रेक लग जाएगा -3 के जस्ट पहले वाली टर्म पे. Is that clear? 193, 186, 179. Let us say -3 is 100th term. So I need the value of n 1 less than 100. Why? Because these two APs can have only maximum 6 common terms. So this is the catch of the question. Okay. So what do we have to do? We have to solve for an equal to just the next term of -3. What will be the next term of -3? It will be 4. So solving for an equal to 4, 193 plus n minus 1 into -7 equal to 4. I will get the value of n as 28. Okay, so 28 is the final answer for question number 44. Let us move on to next question, that is question number 45. 45 says that the position vector of point P is r vector equal to xi cap minus yj cap plus zk cap, and a vector is I cap minus 2j cap plus k cap. If r dot a equal to 12, then the number of possible positions of point P. Carefully see students, x, y, z all belongs to natural numbers. So let us take r dot a equal to 12. It will give me x plus 2y plus z equal to 12. So in fact, it is a question of number of positive integral solutions of the equation that corresponds to the topic permutations and combinations. It is not a question of vectors. Okay. So x plus 2y plus z equal to 12. I'll have to take different cases. Y equal to 1. Then x plus z will be equal to 10. Y equal to 2. Then x plus z will be equal to 8. Y equal to 3. Then x plus z will be equal to 6. Y equal to 4. Then x plus z will be equal to 4. Y equal to 5. X plus z will be equal to 2. That is the last case because x, y and z all are natural numbers. Okay. So for natural numbers, what is the answer? There are total 9 possible cases here, 7 possible cases here, 5 possible cases here, 3 possible cases here, and only 1 possible case here. So you know the formula, n minus 1c r minus 1. That is the result. 9c1 for first, 7c1 for second, 5c1 for third, 3c1 for fourth, 1c1 for the last one. So the answer is sum of first 5 odd natural numbers. That is n square, 25. Okay, 25 is the answer for question number 45. Let us move on to 46. Question number 46 says that if 12 plus 7 root 3 whole raised to the power 2n plus 1 is equal to p, and q is the fractional part of p, and the number of divisors of pq is 30, then what is the value of n? Now this is a perfect mixture of binomial theorem and permutations and combinations. The value of p is 12 plus 7 root 3 whole raised to the power 2n plus 1. So p is 7 root 3 plus 12. We generally write the larger term first. 7 root 3 is a value which is more than 12 because its square is 147. 12 square is 144. This value is equal to some integral part, i.e. let us say, and q is given to be the fractional part. Okay. Then I will assume one more value as q dash. 7 root 3 minus 12 raised to the power 2n plus 1. Q dash lies between 0 to 1. Because this is a fraction, whole raised to the power 2n plus 1, definitely a fraction. Q is also lying between 0 to 1 because it is the fractional part of p. Let us subtract them. P minus Q dash. So you know that in the first term, that is P, we have 2n plus 2 terms. Second term Q dash, we have 2n plus 2 terms. Half of the term will be cancelled. I'll have 2 times into some integer value over here. That means it is an even integer, because all the powers of root 3 will be even. So that means this particular bracket, square bracket, is an integer. P minus Q dash is an even integer. P is I plus Q minus Q dash equal to integer or even integer. I can say that I is also an integer. On the right hand side I have even integer. So Q minus Q dash has to be an integer. Q also lies between 0 to 1. Q dash also lies between 0 to 1. That means Q equal to Q dash is the only possibility. Okay. What is P into Q now? P into Q is I plus Q into Q. And Q is already Q dash. So I plus Q into Q dash means the product of first 2 terms. This term and this term. A plus B, A minus B. So A square minus B square, 147 minus 144 whole raised to the power 2n plus 1. That means it is 3 raised to the power 2n plus 1. The question says number of divisors of PQ is 30. Number of divisors of 3 raised to the power 2n plus 1 is 2n plus 2. This is given to be equal to 30. Obviously, the value of n will come out to be equal to 14 in this case. Okay. Answer for this particular question is 14. Let us move forward to question number 47. Question number 47. Consider a triangle ABC whose sides are small a, small b, small c. They are in AP. So let us first of all start the question with the relation of AP, that is 2b equal to a plus c. Now, if the value of angle A when angle B is maximum is x degree, I need to find the value of x. So let us start with cos B. Cos B is a square plus b, c square minus b square upon 2ac. So this is a square plus c square minus a plus c by 2 whole square upon 2ac. So we can see that we'll be getting 3a square by 4 plus 3c square by 4 minus I'll be getting 2ac by 4. So ac by 2 upon 2ac. So this will be 3 by 8 a by c plus c by a minus 1 by 4. Students, you can analyze that I have converted it into the form of a by c plus c by a. A and c are the sides. Obviously, a by c is a positive number. Applying AMGM inequality, I get a by c plus c by a greater than equal to 2. Cos b is greater than equal to 3 by 8 into 2 minus 1 by 4. That is 3 by 4 minus 1 by 4. That is 1 by 2. Cos b is greater than equal to 1 by 2. Obviously, it is less than equal to 1. So b lies between 0 degree and 60 degree, because cos is a decreasing function, so the inequalities will be reversed. Okay, 1 by 2 is cos 60, 1 is cos 0. So b lies between 0 to 60 degree. Question says that when b is maximum, what is the value of angle A? When b is maximum, that means b is equal to 60 degree. If b is equal to 60 degree, cos b is exactly equal to half. That means this value is exactly equal to 2. That means a by c is equal to c by a, because that is the minimum sum of a number and its reciprocal. Okay, given the number is positive. So a by c equal to c by a. The condition of am equal to gm. A equal to c if side a is equal to side c, angle a is equal to angle c, and if angle a is equal to angle c and angle b is 60, obviously all the angles are 60. Okay. We have the answer of this question as an equilateral triangle according to the given conditions. X degree is the answer, then x is equal to 60. Okay. Let us move on to question number 48. Question number 48 says that the number of solutions of the equation secant 2x into sine 4x is equal to 2 sine 2x into tan x lying in the interval 0 to 6 pi. No doubt, students, it seems a very simple problem at first glance, but it is a very dangerous one because you have to take care of the domain. Okay. So the question is secant 2x into sine 4x is equal to 2 sine 2x tan x. We have two trigonometric ratios in the denominator if we expand everything in sine and cos. Secant 2x will give you cos 2x in the denominator. So cos 2x cannot be 0, and tan x will give you cos x in the denominator. So cos x is non-zero. You have to eliminate those solutions for which these two conditions are getting violated at the end. Okay. So let us simplify this one now. This is 2 sine 2x cos 2x secant 2x, which is obviously 1. 2 sine 2x tan x. 2 is also cancelled. Secant 2x into cos 2x is 1. So sine 2x is equal to sine 2x into tan x. So sine 2x into 1 minus tan x equal to 0. Okay. So sine 2x is 0. Tan x is 1. Carefully, students. All the points where tan x is 1, cos 2x is 0. That means this is not possible. Tan x is 1 at x equal to pi by 4. If x is pi by 4, 2x is pi by 2. Cos 2x is 0. Tan x equal to 1 at x equal to 5 pi by 4. Again, cos 2x, 5 pi by 2. Again 0. But it cannot be 0 according to the domain of the given problem. That means we have no solution from here. Okay? No solution. A very important step in this question. Sin 2x equal to 0. So 2 sin x into cos x equals 0. According to the domain of this question, cos x is not 0. That means the only possibility remains sin x equal to 0. Now this particular equation is perfectly fine with the domain of the given question. Sin x equal to 0 does not give any problem with cos x or cos 2x being 0. Sin x equal to 0, what are the solutions? X equal to n pi. The interval is open 0 to 6 pi. So pi, 2 pi, 3 pi, 4 pi and 5 pi. Total number of solutions 5. Answer to this particular question is 0, 5 because you have to fill a double digit in the OMR. Okay. Let us move on to question number 49. Question number 49 says that consider a square matrix B of order 3 such that B is equal to A into adjoint of A inverse whole inverse and then again its adjoint, that is the outermost adjoint, okay, where determinant A is equal to 1 by 3. If determinant B is equal to P upon Q, where P and Q are co-prime numbers to each other, then the value of modulus of 3P minus 2Q is equal to what? So what we have to do, we have to directly target ourselves at determinant value of B. One more point to be noted in this question is that the order of matrix B is given to be 3. Matrix B is equal to adjoint of A into then again some operations which are inverse and adjoint for this particular matrix A. So you must note that A inverse and A, adjoint A and A have the same order. So if the order of B is 3, then order of A is also 3. Okay. So B is related to A, order of B is same as order of A. So let us take the determinant straight away. Determinant of B is determinant of adjoint of A, adjoint A inverse, whole inverse. Determinant of adjoint of a particular matrix is determinant of that matrix raised to the power n minus 1. The value of n is 3. So the answer is determinant of A into adjoint A inverse whole inverse raised to the power 3 minus 1, that is 2. This is the inverse of A into adjoint A inverse. So the determinant of inverse is raised to the power minus 1. So this minus 1 and minus 2 will be multiplied. So this is determinant of A into adjoint A inverse raised to the power minus 2. Determinant of product of two matrices is determinant A into determinant B. So this is product of two matrices. Determinant A raised to the power minus 2. Determinant of adjoint of A inverse raised to the power minus 2. Determinant of A is 1 by 3. Determinant of A raised to the power minus 2 is 9. Determinant of adjoint of a matrix is again determinant of that matrix raised to the power n minus 1. Determinant of A inverse raised to the power n minus 1, that is 2, whole raised to the power minus 2. So this becomes minus 4. Determinant of A 1 by 3. Determinant of A inverse 3. So this is 9 into 3 raised to the power minus 4. That is equal to 1 by 9. That means P is equal to 1, Q is equal to 9. Modulus of 3P minus 2Q. 3 minus 18, answer of this particular question is equal to 15. Okay, 15 is the answer for question number 49. Let us move on to question number 50. Question number 50 says that the number of terms in the expansion of 1 minus x square whole raised to the power 20 into 1 plus x square plus x raised to the power 4 whole raised to the power 22. So we know that this particular question is in the form of a minus b raised to the power 20 into a plus ab plus b square raised to the power 22. So let us separate the power 20 from the expression. That means I need 1 plus x square plus x power 4 into 1 minus x square whole raised to the power 20 into x power 4 plus x square plus 1 whole square. 20 plus 2 is 22. The square bracket reduces to a cube minus b cube. That is the identity. So 1 minus x raised to the power 6 whole raised to the power 20 into x power 4 plus x square plus 1 whole square. Now students, you have to count the number of terms. By number of terms, I mean that the power of x should be different. Okay, so let us carefully expand them and quickly count how many number of terms are there. This will be c0 minus c1 x raised to the power 6, c2 x raised to the power 12, c3 x raised to the power 18, so on, c20 x raised to the power 120. Let us expand the second term, x power 4 plus x square plus 1 whole square. Obviously, you will get x power 8 in the first term. Then you will get x power 6, 2 into x power 6. How you will get it? By multiplying 2ab, x power 4 into x power 6. Then you will get x power 4, 1 from the x square term and 2 from x power 4 into x power 1. So 3x power 4 plus. Then you will get x square term when 2 into x square into 1 will be multiplied. And at last you will get one term. Okay. Obviously, we are going to multiply each term in the first bracket into each term in the second bracket and nullify the alike terms. Okay. 21 terms are there in the first bracket. 5 terms are there in the second bracket. When we will multiply 21 terms with x power 0, we'll get 21 terms completely different. With x power 2, again completely different. With x power 4, again completely different. But when we will multiply it with x raised to power 6, notice that the difference here between the two consecutive terms is the difference of x power 6. So when you will multiply 2x raised to power 6, all the terms will be same as when you multiplied with x power 0, that is over here. But there will be one difference, x power 6 into x power 120, x power 126. That term has not come before. So only one term will be added because all the other terms are already counted. Okay, x power 6, x power 12, x power 18, they are already counted. Going on to the last term, x power 8. X power 8 has the same story as x power 2 except the last term, x power 8 into x power 120, x power 128. This is the final answer. Very carefully, the answer is 65. Okay, answer to last subjective question is 65. Let us move on to the paragraph section now.